function. Well, what do you have to multiply by? The derivative of this. What do you have to do to find the derivative of x cosine x? What rule do you have to use? Product rule, yeah. So it's e to the x cosine x times, there are two functions. What's the derivative of the first function? 1 plus x. What's the derivative of cosine? Negative sine x. I would like you to clean this up just a little bit and turn it into e to the x cosine x times cosine x minus x sine x. That would be great if you left the answer like that. So we had to use, what rules did we use? We used the chain rule, and then inside the chain rule we use the product rule. Two different rules right there. Two different rules. But that's what you'd end up with. Yeah, it doesn't matter if it's cubed. No, what's the definition of a constant? Without using the word constant. Unchanged, right? So if the derivative is a measurement of rate of change, what's the rate of change of something that isn't changing? 0. So into a 0 plus, and remember, what is this means cosine cubed. So it's the quantity cosine being cubed. So you drop the 3 cosine x to the what power? And then you multiply by the derivative of cosine, which is negative sine x. You know, so y prime is equal to negative 3 sine x times, and you could write it like this, times cosine squared x. That's fine. Yeah, go ahead.
It was like cosine 2x.
Yeah, don't multiply it out. That would be horrible to multiply out. Like terrible, terrible, terrible. I mean, when you're done, you'd have at most you'd have 8 terms, which isn't that bad. Like if you had an 8th degree polynomial, that's not bad. But getting there and simplifying it, are you going to make a mistake? Yes, absolutely. If you ever needed to multiply that out, what would you use? Let's say I asked you, you had a computer and you had that. Do you have any idea how you would quickly multiply that out? Plug it into what? Yeah, plug it into Wolfram Ralph. Product rule. Please use the product rule. So the product rule is the overall rule you're going to use. But inside the product rule, what are you going to have to use? The chain rule. What's the first function? There, and that's the second function. So g prime is going to be the derivative of the first, which is 5 times 1 plus 4x to the times 4. The derivative of the first times the second plus the first times what? 8. The derivative of the second plus what? X. Minus x squared to the times 1 minus 2x. Stop there. Please, stop. Just stop. I'm testing you right now whether or not you can apply the product and chain rule. I'm not testing on algebra that you're probably... Yeah, so it's y equals x plus x to the 1/2 all to the... Yeah, so what's the overall rule you're going to use here? Chain rule. Y prime, what do you drop to the front? Times what's on the inside to the what power? Times the derivative of the inside, which is 1 plus x to the... Done. Stop there. Stop. How? Okay, so on 40, it's a similar process, but it's a little bit bigger. How many times are you going to have to use the chain rule here? 3 times. Well, it depends on how you define use the chain rule. How many times did we use it on this one? Well, once. We used it once. So really here you're just using it twice. You have 2 embedded functions, the square root twice. So what's the first thing you should do? Yeah, and I'll use brackets now. You end up with x plus x to the 1/2 to the... The best thing you can do is make sure you clearly write your answer. The worst thing you can do is make a mess of this by being lazy with parentheses. Y prime equals 1/2 times x plus x to the 1/2 to the 1/2 to the what power? Times the derivative of the inside, which is going to be 1 plus 1/2 x plus x to the 1/2 to the what? But what do you have to multiply this by? 1 plus 1/2 x to the... There it is. You had to use the chain rule how many times? Twice. Chain rule twice. You need. And what do we have? So all we need is slope. So to find the slope, we need to find the. Yep. What rule are we going to use? Product, and inside the product rule, we're going to have to use the chain. Y prime on 46, the derivative of the first times the second, plus the first times the derivative of the second. But what do I have to multiply by right there? Y. Because of the chain rule, it's the derivative of negative x. Now, what are you evaluating this at? What are you plugging in? 1. End up with 2e to the negative 1 plus e to the negative 1 times. So you end up with 2 over minus, which equals 1 over e. You know, that's how I would write it. So write the equation now. Do you have to write it in any specific form? What form do I prefer? Y minus is equal to, and stop there. Don't go any further. Unless there's a specific reason to. Do you need to rewrite that? No. Where'd the slope go? You know this. The slope went right there. Is it just a it is just a happenstance that the y coordinate here is the slope as well. Just a happenstance. What rule do you have to use to find h prime? The chain rule. What is h prime going to be equal to? Someone raise down and tell me what h prime is equal to. Biggie. G of x times what? G prime. Correct. So what does h prime of a half equal? F prime of g of a half times g prime of a half. Do we know what g of a half is? So h prime of 1/2 is equal to f prime of, what's g of a half? 0.1. What's g prime of a half? Does it give us it? What was that nasty equation? It was x cubed plus y cubed is equal to? Y is some function of x, so x cubed plus f of x cubed equals 6x times f of x. What's the derivative of x cubed? Plus 3 f of x to the what power? Times. And what rule do we have to use on the next part? Product. The derivative of the first. What's the derivative of f of x? Plus. No, I just factored the 6 out. Oh, I did the. Oh, what was wrong? Oh, don't do that. The derivative of the first times the second plus the first times the derivative of the second. What can we now isolate? Yeah, we can isolate f prime. In order to isolate f prime, what am I going to need to do first? Get them on the same side, exactly. So you end up with 3 f of x squared f prime of x minus 6x f prime of x. And what's that going to equal? 6f of x minus what? 3x squared. So what's f prime of x going to be equal to? 6f of x minus 3x squared all over what? Minus what? And remember, what is f of x? Y. Yeah, f of x is equal to what? Y. So how can we rewrite this? F prime of x is equal to minus. There's your derivative. Is our derivative a function? No. When we needed a derivative before, we only needed to plug in an x value. But now we're dealing with things that aren't functions. So one x value, how many outputs can an x value now have?
2.
Or 3 or 4 or 5, right? If I gave you this folium and said, okay, the x value is 1, what's the y value? How many answers can you give to that question? 3. There's 3 of them, right? 1, 2, and 3. So if you want the rate of change at a point, you can't just plug in x. You need to plug in x and y. So let's go back to this for a sec. This is nice because all we have to do is find the point, and this will give us the rate of change at any point on that folium. The substitution I'm doing here, do you see how I plug in f of x for y, and then at the end, what did I do? I plugged in f of x for y, and then I reversed the substitution. You're eventually not going to need to do that. You're just going to be able to write, every time you see y, what's the derivative of y? Y prime. When you're doing it in terms of x, when you're doing the derivative in terms of x.